Students, this is the second part of the interactive session for class 10th, subject physics, and it is being submitted to you on 5th April 2021. In this session, we will study about the concept and applications which are based on the concept for the moment of force. Children, basic thing which we have to understand here is larger is the perpendicular distance of the line of action of applied force from the axis of rotation, less is the force needed to produce the same turning effect. That is, if the perpendicular distance between the force applied and pivoted point is more, then the torque, same torque can be produced by applying a very less force. For clearance of this concept, kindly see table number 1, in which we basically need to produce a torque of 100 Newton meter. Children, see table number 1. It is given on page number 4 of the notes sent to you. So children, I want to apply a force of 100 Newton meter. What we require? We require a torque whose value should come 100 Newton meter. Okay. Just remember the formula of torque. Torque is, what is the formula of torque? Force into perpendicular distance. Now, if I apply a force of 20 Newton, or you say if I take a distance of 5 meter and I need a force of 100, I need torque 100 and I am having a perpendicular distance of 5. So how much force is needed? That is 100 by 5 comes out to be 20. Fine. So what does it mean? It means that at a distance of 5 meter, I need to apply 20 Newton force to get the torque of 100 Newton meter. See now, 20 multiplied by 5 is 100. Is it clear? Similarly, if I want to apply a force at 2 meter, if R is 2 meter, I need answer of 100. That means I have to apply a force of 50 Newton. 50 into 2 will give you 100. Similarly, at a distance of 10 meter, I need to apply a force of 10 Newton to get answer 100. At a distance of 50 meter, how much force is required? See, at a distance of 50 meter, I need to apply 2 Newton force such that 2 into 50 becomes 100. Similarly, 40 Newton and this is 2.5 meter. So 40 into 2.5 meter will be 100 Newton meter. So what can we see from the pattern? In every case, what I have done, I have changed the distances, and according to the distance, my forces are changing to get the same answer of 100 Newton meter. Fine. 20 multiply by 5 is 100. 50 into 2 is 100. 10 multiply by 10 is 100. 2 into 50 is 100. 40 multiplied by 2.5 is 100. So children, now you observe the table carefully yourself, since I'll be asking two questions and you have to answer it by looking at the table only. So the first question is, at what distance we need to apply more force to produce a torque of 100 Newton meter? Out of all these distances, tell me at what distance you are applying maximum force to get 100 Newton meter as your answer. Okay? And then question number 2 is, at what distance from the pivoted point we need to apply the least force to produce a rotational effect of 100 Newton meter. So your two question is, firstly, you have to write down that distance where you need to apply more force. Question number 2, write down that distance where you are applying least force. So see, where is the maximum force here? What is the value of maximum force applied here? What is the maximum force applied? 50 Newton is maximum? Yes. So 50 Newton is your maximum force applied. And at what distance? At a distance of 2 meter. So at a distance of 2 meter, you are applying maximum force. And your minimum force is 2 Newton, which is applied at a distance of 50 meter. See, when your force is minimum, your distance is maximum out of the table. So what do we conclude from here? What can be concluded? So it can be concluded that more is the perpendicular distance between the line of action of force and the pivoted point, less force is required. You will be needing less force to produce the required torque. So children, there is one thing you can try at your home. Try to open the door of your house by pushing it from a point near to the hinges. Now you see figure number 2 here. This is the point A. It is near to the hinges, and this is your doorknob B. First, you try to apply the force and pull the door towards yourself from point A. Or you can push it away from point A, and then later on push it from point B. And you will experience the same thing. Since A is closer from the pivoted point as compared to B, the force required to push the door from B is less as compared to force required to push it from point A. This is the reason why the handles or the door knobs are always placed at the maximum distance. Why the doorknobs are not placed at the center or near the hinges? Because you have to apply more force to open or close the door there. Now students, moving to the examples of moment of force, which are based on the concept which we just understood. First example is of hand floor grinder, which is commonly known as chakki. So the upper circular stone, they are basically two stones, lower stone and upper stone, and in the center we put grains inside it, while there is a handle at the rim, at the boundary of the stone, and to rotate it, to produce the rotational effect, we have to apply the force on this rim. This rim is not situated near the pivoted point, because if it is near the pivoted point, more force has to be applied to rotate the stone. It is basically at the farthest end, such that very less force is applied and it is easy for you to rotate the stone. So children, the upper circular stone of a hand floor grinder is provided with a handle near its rim, that is at the maximum distance from the center. Children, center is the pivoted point here. It is constructed in this manner so that it can easily be rotated about the iron pivot at its center by applying a small force at the handle, which you can see in figure 3. The handle is placed at the rim so that the perpendicular distance of the line of action from the axis of rotation will be maximum, so as to get the maximum turning effect. Now children, I want you all to pay attention and see how the rotation effect is taking place in this hand floor grinder. See, the grains are poured at the center pivot point, and now this is being churned from the boundary. See, now when it is churning, when you are applying force, the handle is placed at the rim. It is not placed at the center, because at the center it will not be easy for you to rotate the hand floor grinder so easily as it is being churned right now in front of you, such that the floor is coming out. See, the grain is being poured and the powdered form of flour is coming out by applying force. This is the way a hand floor grinder works. Now coming to example number 2. See figure number 4 on page number 6 of the PDF. In figure number 4, a spanner is provided with a long handle. Children, in figure number 4, you can see a spanner which is used to open nuts. Now what happened here? The nut or bolt is at one place while you are applying force at the corner at one of the end of the spanner. If you apply force from the center, you need to apply more force, because the pivoted point or the fixed point of the spanner is where the spanner is stuck inside with the nut. That becomes your fixed point, pivoted point. And the distance between pivoted point and force, if it is less, you need to apply more force. Therefore, the force is always applied at the handle end, at the other opposite end. Now students, I'm giving you a question. So kindly go through the question carefully and then write down its answer in your physics notebook. Children, a boy is trying to release a nut with a spanner. You can see figure number 5 for reference. In figure number 5, It shows the size of the force he is applying, he is exerting, and where this force acts on the handle. It is shown. Okay. So there are two parts of the question. My first part is the spanner applies a moment or turning effect to the nut. Calculate the magnitude of this moment or turning effect. Children, moment or turning effect means torque. So kindly calculate the value, the magnitude of the torque. And B part is give two ways, two methods, two ways in which the boy could increase the moment he applies using this spanner. Write down two ways how can the boy increase the torque of this spanner. Kindly write down the answer in your physics notebook, and then you can resume the session further and cross-check your answer. So by now, I hope you must have written the answers. Let's cross-check it. First answer of finding the value of torque can be found by using the formula torque is equal to distance multiplied by force. So the distance given was 7 centimeter converted into meter, while force is Newton, 90 Newton. So children, here 90 Newton multiplied by 7 centimeter. 7 centimeter can be written as 0.07 meter. So 90 multiplied by 0.07 will be 6.3 Newton meter. So the value of torque is 6.3 Newton meter. And the second part, the two ways which we have to write. The first way can be the boy can increase torque by increasing the magnitude of force applied. By increasing the magnitude of force applied. And secondly, it can also be done that the force applied should not be at 7 centimeter. Rather, you increase the distance from the pivoted point to increase the torque. So therefore, the second way can be by applying the force at the farthest point from the net. From the nut, you take the farthest point. So now let us move to the other example. Example number 3, for which I want you all to see figure number 6. This is a jack screw, students. A jack screw is used to lift a vehicle, especially when you are having a problem of flat tire. Here you are having arm of jack screw, which is having a longer length. The length of arm of jack screw is more. Why so? We have to apply the force at the end here, and such that maximum rotation can take place. So as it can be seen in figure 6, a jack screw is used to lift a heavy load, heavy weights such as vehicle, and it has a long arm. Why so? So that less effort is needed. Very less effort means less force is needed to rotate it. When it will rotate, then it can raise the load also. So now let us do few numericals, students. Let's do certain examples here. First is A mechanic can open a nut by applying a force of 156 Newton while using a lever handle of length 25 centimeter. So how long a handle is required if he wants to open it by applying a force of only 40 Newton? So right now what is happening? Mechanic is using a force of 156 Newton at a distance of 25 centimeter. Let's find the value of torque. First case is we'll use first two values to find the value of torque. Pay attention, children. 25 centimeter is needed to be converted into meter. That means either you can say 0.25 meter or 25 multiplied by 10 raised to power minus 2 meter. Then multiply R and F. Your answer comes out to be 3900 multiplied by 10 raised to power minus 2, which is basically 39 Newton meter. Now we know that torque required to open a net is 39. So now let us move to the further line. How long a handle is required if he applies a force 40 Newton. So children, in case 2, I have to find distance. Force is 40 Newton and the torque will be taken as 39 Newton meter. Put the values to find the answer of the distance, which will come out to be 0.975 meter, or you can say 97.5 centimeter. Similarly, question number 2, a nut is opened by a spanner of length 15 centimeter if the least force required is 10 Newton. You need only 10 Newton force. Find the moment of force, or you can say find the torque needed to turn the nut. So that will be R multiplied by F. Put the values and your answer will come as 1.5 Newton meter. Again I repeat, 15 centimeter is to be converted into meter. That is 15 by 100. And then your answer will come 1.5 Newton meter. So children, with this, I'm ending today's interactive session and you all are required to write the answers of the tick marked questions. That is from question number 8 to question number 14 in your physics notebook, and kindly write down all the reason questions in detail. Thank you, students, and have a nice day.